Chapter 36, Geometric Optics. Now that we have the Snell's law of reflection and refraction, we are able to apply these laws to study various cases of image formation. And this is the subject of this chapter, Geometric Optics, in which we study how an optical instrument can form an image. And again, the laws that we're going to use would be the Snell's law. There are two cases, of course, for the Snell's law, reflection and refraction. When an image is formed by reflection, the instrument involved is called a mirror. As you know, we can either have a plane mirror or a curved mirror. We'll study both cases. And if the image is formed by refraction, then the instrument in question is called a lens. I'm sure you have seen both cases. Now we're going to study them systematically. Now let's review the idea of an image, an optical image in general. We here have an object, okay? And light rays, you can imagine light rays coming out of this object. These light rays will be passing through or getting reflected by a set of optical instrument. This can be a mirror, can be a lens, can be the combination of both, and so on. And whatever happens, after the light rays get processed by an optical instrument, they come this way. Okay, they merge at that point, and that point would be the image formed by this object due to the optical instrument in question. Again, if the optical instrument is of a mirror type, then it forms an image by reflection, and if it's of a lens type, it forms an image by refraction. Now, when it comes to optical images, there are two types of optical images that we have to distinguish. One is called a real image, and the second type is called a virtual image. Okay, here's the case of a real image. I have light rays coming in, okay? They actually converge at that point before reaching our eyes. This is a real image because actual light rays pass through that point, and that point would be illuminated if I put a screen here. Okay, if I put an actual screen here, there will be a bright dot on that screen, meaning light actually pass through that point. Okay, this is the case of a real image. What is a virtual image? Well, here's an example of a virtual image. I have a beam of parallel light, which do not really converge to any point, but then I put a piece of instrument here, optical instrument. I'll show you examples how to do that. And what that piece of instrument does is that it causes the light rays to go sideways like this. Okay, it causes to go sideways like this. And we look at these light rays. This is our eye. We look at these light rays. And what do we see? Well, we see these light rays coming towards our eyes, and they appear to be originated from there. Now, is there really something there? Not really. The light rays are like this. Okay? Nothing is really there. This is not where light rays actually originate, but it just appears to be so. In fact, look at these two cases. Look at these two cases. Here we have light rays going this way, coming from a real point. Here you get light rays which appear to be diverging in the same case as that, except that they do not really come from that point, but they appear to be doing so. This is an example of what's called a virtual image. Okay, no light rays actually pass through that point, but it can nonetheless still be very convincing. The most famous example of a virtual image would be that formed by a plane mirror. You know, when you look at a mirror, you see yourself. That image is definitely virtual because that image is formed behind the mirror, and of course behind the mirror there is no light. It's dark, right? So obviously no light can pass behind the mirror. The image formed is a virtual image. We'll see. We're going to study both real and virtual images formed by both